Okay, welcome back. So in the last video, we talked about inverses of matrices, right? And how we denoted the inverse of a matrix A. So if I have a matrix A, so matrix A, then we would say that the inverse of that matrix, we write that with a little -1 power on it. Okay, so that's what the little -1 power means. When you put it on a matrix, it means you're doing the inverse of the matrix A. Okay, and remember what defines the inverse was we wanted to have A times A inverse, and we wanted to get the identity matrix, right? The matrix with ones across the diagonal and zeros everywhere else, okay? So that's, and again, also that A inverse times A is also I, okay? So that's what we needed to have happen for the inverse, okay? And so what we're going to look at in this video is, in the last one we checked that a matrix was the inverse of another matrix, and how we did that, right, was we multiplied the two matrices together in both orders and checked that you got the identity matrix both times, okay? In this video, what we're going to look at is, what if I have a matrix and I want to find the inverse, okay? So I'm going to start with a matrix here. Find the inverse of the matrix. I will say, this is my matrix, 1, -2, -4, 2, -3, -6, -3, 6, and 15. Okay, so let's say that this is my matrix that I'm dealing with, and I want to, instead of being given the inverse, let's say that I want to find the inverse. How could I actually find that out? Okay, well, essentially what we want to have happen is, when we multiply this matrix by the inverse, we want to get the identity matrix, okay? And I know the process that I'm going to teach you is maybe a little weird. You may not see why it is that it works, but it does actually give you the inverse when you do this, okay? So how you perform this, this algorithm is, you're going to take your original matrix, okay? So I'll take my original matrix here. Okay, so that's my matrix. And what you're going to do is you're going to throw on to that matrix the identity matrix of the same size. Okay, so in this case, I'm working with a 3 by 3 matrix. I'm going to draw a little dotted line here so that I keep track of what I'm doing here. And what I'm going to do over here is I'm going to put in the 3 by 3 identity matrix. So that's ones down the main diagonal, okay, and zeros in all the other positions. Okay, so that's step one. We sometimes call this augmenting, when you throw another matrix into a matrix that you have. Okay, so we're putting the identity matrix in here because we want to end up, when we multiply this matrix by the inverse, we want to get the identity matrix. Okay, so we're putting the identity over here because that's what I want to end up with. Okay, and then what you are going to do, okay, what you're going to do is you're going to do row reductions on this. So if you remember doing row reduction when we were solving systems of equations before, you're going to do that same process. So I'm going to row reduce. So you're going to row reduce this matrix here so that essentially you will end up with the identity matrix over here. Okay, ones along the diagonal and then zeros everywhere else. You want to end up with the identity matrix here. And then whatever is over here on this side, after you do your row reductions, whatever is over here, that is going to be your inverse. Okay, so we're going to row reduce this to get the identity matrix on this red part of the matrix. Okay, so let's go ahead and start our row reduction, right? And so our first step with that is we want a 1 up here in this corner, and we already have that, so we're okay there. Okay, so we'll leave that 1 there. Okay. So that row is going to stay the same. But I also want to get rid of the 2 numbers below that leading 1, right? I want to get those to be 0. Okay. So what I'm going to do is I am going to take multiples of this first row and add it to the second row. So to get rid of this 2 here, I'm going to have to times this top row by -2 and then add it to the second row. Okay, so I'll keep a little note here. This is kind of a big matrix, but we're going to do -2 times the first row, and we're going to add it to the second row. I'll maybe put parentheses. You don't need parentheses. I'll just put it like that. Okay, so I'm doing -2 times the first row, and I'm going to add it to the second row. Okay, let me get my I'll do a green marker. Okay, so -2 times 1, and then +2 is 0. -2 times -2 is 4, plus -3 is 1. -4 times -2 is 8, is 2. Okay, and then I do the same thing over here too. I do -2 times 1 is -2. Okay, -2 times 0 is 0, plus 1 is 1. Okay, and then -2 times 0 plus 0 is 0. Okay, so that's my second row there. Now, what we want to do is we wanted to get a 0 right here too, okay, in this corner. So I'm going to do another row operation. To get rid of this -3 here, I'll do 3 times the first row and then add it down to the last row. So I'm going to do 3 times the first row and then plus the third row. Okay. So what happens when we do that? We get 3 times 1 is 3, plus negative 3 is 0. 3 times negative 2 is negative 6, plus 6 is 0. 3 times negative 4 is negative 12, plus 15 is 3. Okay. And then do these ones as well. So negative 3 times 1 is negative 3, plus 0 is negative 3. Or sorry, positive 3, because we're doing positive 3 times row 1. Okay. So positive 3 times 1 is 3, plus 0 is 3. 3 times 0 is 0, plus 0. So that's 0. 3 times 0 is 0, plus 1 is 1. Okay? So this is actually quite a nice one to do, because we're already pretty close to the identity matrix. But we do have a little bit that we still have to do. Okay? So let's go ahead and look at what have we got here. Well, we're trying to get an identity matrix here, right? So we want 1s on the main diagonal. We've already got a 1 here and 0s below it. Notice I also have a 1 here now, which is good. That would be my next step if I was row reducing this and there wasn't a 1. I would make that a 1 and then use that to get rid of what's below. Okay, but it's already gone. So we're okay there. This is all taken care of. So now we should move on to this last place where we could have a leading 1, which is right here. Okay, and so I want to get that to be 1. So I'm going to just take this row. So my new matrix is going to be like this. I'm going to take that row, and to get rid of the 3 here and make it be a 1, I'm just going to do 1/3 times the 3rd row. Okay. So what will that give me? The top 2 rows stay the same. Okay. It's just the bottom one that changes. So 1/3 times 0 is 0. 1/3 times 0 is 0. 1/3 times 3 is 1. And 1/3 times 3 is 1. 1/3 times 0 is 0. And 1/3 times 1 is 1/3. Oh, and I missed a row over here. Here, let's throw this in. -2, 1, 0. Okay. Sorry, it's kind of late at night, so I keep yawning. So we got almost a identity matrix over here, right? I now have a leading 1 here. To get an identity matrix, I need there to be zeros over here, right? So I do the same thing as Gauss-Jordan elimination. I get rid of these, so I get those to be zeros, and then I get this one to be 0. Okay? So to do that, let's draw in some brackets here. So to get these 2 spots to be 0 above this 1, we need to times this by -2 and then add it up here to get rid of that one. So I'll do -2 times row 3, and I'll add it to row 2. And then I will also need to get rid of this -4 up here. So I'm going to have to do 4 times this 1, add it up there to get rid of that. So I do 4 times row 3, and I'm going to plus row 1. Okay, I'm going to do both of those in the same shebang. Okay, so my last row is going to stay the same because I'm just using that to add up to the other ones. Okay, so we got that. So then I'm going to do -2 times row 3 and add it to row 2. So -2 times 0 plus 0 is 0. Notice that's not messing things up. -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, and adding up is 0, which is what we wanted to have happen, right? -2 times 1 is -2. Add up to -2 is -4. -2 times 0 is 0, plus 1 is 1. -2 times 1/3 is -2/3, plus 0 is -2/3. Okay, so we got a 0 right here. Now to get a 0 up here, we do 4 times the third row, and we add it to the first row. Okay, so 4 times 0 is 0, plus 1 is 1. 4 times 0 is 0, plus up there is -2. 4 times 1 is 4, and then add to -4 is 0, which is what we wanted. Okay, 4 times 1 is 4, plus 1 is 5. 4 times 0 is, well, yeah, 4 times 0 is 0, plus 0 is 0. And then 4 times 1/3 is 4/3. And then we're going to add it to 0, so 4/3. Okay. Oh, man, I need to film these earlier because I'm too tired tonight. Yeah, so we got there to be zeros right here. Okay, and so now we're really close to the identity matrix. We just need to get rid of this -2 right there. Okay, and so to get rid of that -2, we are going to, well, it looks like I'm about out of space, so let me get another board here. It's about 9:40 on this Friday evening of spring break. I'm in my room filming some videos for you. Normally I don't do it this late, and so I apologize about my yawns. Okay, so we are almost there. We just need to get rid of this -2 there. Okay, so let me write a new thing here. Okay, so to get rid of that -2, and I also don't want to mess up the other stuff I've done, so I'm going to use the second row to get rid of that -2 because that won't mess up the other stuff I've already done. Okay, so to get rid of that -2, I'll use my 1. I need to times it by 2. Right, so I'm going to do 2 times row 2, and then I'm going to add it up to the first row. Okay, And so what do we get here? We do 2 times this row, and we're going to add it up. Well, 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2. Added up is 0. Okay. 2 times 0 is 0, plus 0 is 0. 2 times -4 is -8. Plus 5 is -3. Okay. And 2 times 1 is 2. Plus 0 is 2. 2 times -2/3 is -4/3. And then we add it up. That's 0. Okay. And so that was our row operation. So the other rows just stay the same, right? You can just copy those straight in. Okay. So what this tells me here is I now have the identity matrix, right? This is the identity matrix. Ooh, I like that red. That's a very bright red. Okay, this is the identity matrix. And so the inverse matrix of the original matrix that we started with, the inverse is this matrix over here. Okay, so it's -3, 2, 0, -4, 1, -2/3, 1, 0, 1/3. Okay, so that is my inverse matrix. And you could check by multiplying this with the matrix that we started out with, which is somewhere over here. So this was the original matrix that we started out with. You could multiply these two together, and if you did it right, or if we did it right, we would get the identity matrix. Okay? And you're probably thinking, why do I care about this? This is so boring. Well, you'll get to see how this helps, especially in solving systems of equations. Okay, so I'm going to do one more example of finding the inverse of a matrix, and it's actually going to be one that doesn't have an inverse, but I'll kind of show you how that works. But anyway, hopefully that kind of helps you be able to find inverses of matrices. For a 2x2 matrix, a smaller matrix than this, just with 2 rows and 2 columns, you do the exact same thing, only instead of the 3x3 identity matrix, you do the 2x2 identity matrix. So you'd just be looking for, you'd put this chunk in, and then you'd try and get this side to match the identity matrix by doing row reduction. Okay, so the process is the same no matter what the size of the matrix is. It's just you change the size on your identity matrix. Okay, so hopefully that kind of helps with that, and I will see you in the next video.